Welcome back for this online session. In the previous class, we have discussed about uh, what is doubly linked list. So in this class, we are going to discuss about the tree. So what is a tree in the nature view? Tree is actually, look at this. So normally what we say, the root at the bottom and branches at the above the bottom, okay, above the root, then leaves at the top of the tree. So this is how the nature lovers can see the tree. How the computer scientists can view the tree. Look at this. We are going to reverse this tree. Actually, nature view of tree. We are going to reverse this. Look at this. Where is my root? Root comes to what? Top and branches next and leaves at the bottom. So totally reverse of our nature view. So wherever the branches are intersect, that point is called as nodes. Let us take the example tree. How to represent the tree? Look at the norm. Okay, actual way of representing a tree. On the right side is a correct way. Each node can have more than two children. So this is not an actual way. Look at this C, D, and E are in circular fashion, but this is not an actual way of representing a tree. Look at the right one, the right side. So this is a graph is a tree. So this is an actual notation of representing a tree. Tree is a non-linear. What is tree? Tree is a non-linear data structure which organizes the data in hierarchical structure, and this is recursive definition. So in the previous case scenario, we have seen the stack, queue, all those are linear data structure. When it comes to this trace is a non-linear data structures which the data is organized in hierarchical structure. Trees are useful for hierarchical data ordering. So example, if we take the example for the tree is the employees of the corporation. So in the employees, the corporation can have president, vice president, manager, worker bee. So look at this example. You have taken a tree. This is a tree example. So president is at the top because he is the owner of the corporation. So he will be the root. So he'll be holding a three vice presidents, VP1, VP2, VP3. And each and every vice president, we have managers. VP1 has two managers, VP2 has one manager, and VP3 has one more manager. And at the manager end, you will be having some worker base. So this is how we can represent the tree for the employee of the corporation. So the president is called as what? Root. He is a root, overall soul for this company. So he will be the root. When it comes to vice president, look at the second level. So this is president is at first level. The second level is what? Second level is what? Vice presidents. So we have the VP1, VP2, and VP3 are called as children's. Children of what? Vice president. Next is what? Managers. All the managers are uh, children of what? Vice presidents. It is a grandchildren of what? Root. And worker B is a great grandchildren, great grandchild of president. And worker B is a child of manager. And worker B is a grandchild of VP2. So this is how we can represent. So as I said, the element of the top of the hierarchy is the root. As you know, the first level, the first node is called as root. The element in the next hierarchy is called as children. Next to root, we have a children. So next to children, what we have a grandchildren. Next to grandchildren, we have a great grandchildren. I think, but the elements which has no next elements which has no children, that is called as slaves, and so on. What a definition! A tree T is a finite non-empty set of elements. One of these elements is called as root. The remaining elements, if any, are partitioned into trees, which are called the subtree of tree. So we'll see some of the properties. The important properties of the tree data structures are: there is one and only one path between a pair of vertices in the tree. Vertices, nothing about here is what? Nodes. We can, in future, we can call it as nodes instead of vertices. The tree with n vertices has exactly n minus of 1 edges. The meaning of the second point is the tree which has n nodes exactly n minus of 1 edges. We'll see all those in the coming slides. The graph is a tree if and only if the minimally connected. So it will be clarified in the coming slides. Any connected graph with n vertices or n nodes has exactly n minus of 1 edges. That's what we discussed in the second point. To gain better understanding about the tree data structures, we'll see the coming slides. So before discussing the trees in depth, let us see some terminologies of this tree. So we're given some terminologies of the tree. Here is what first tree terminologies. First one we come to what? Parent, next child, sibling, degree, internal node, left node, leaf, depth, height, subtree, forest, root, and finally edge. We'll see one by one. Let us discuss the root. What is root? So it's always the first node of the uh, tree, which is at the topmost node under level 1. We call it as root. So this is the root in this binary, in this tree. In this tree, we take node number A as what? Root. Next, what is the edge? It's a connection link between. It's a connecting link between two nodes. There's a connection link between two nodes is called as edge. So I have taken as node A and node C. I have two nodes, node A and node C, which are connected with a link. This link is called as edge. Like this, B and A, B and A, and D and B, E and F. So all these are edges. So as we know that in a tree with n number of nodes has exactly n minus of 1 edges. So how many number of nodes are there here? So 5 plus 3, 8, 8 plus 3, 11. Totally I have 11 nodes. So how many edges are there? It should be 10. So count, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have how many edges in this tree? We have 10 edges. Why? Because it has 11 nodes. Number of edges in this tree is what? 11 minus of 1, it is 10. So what is a parent node? The node which has a branch from it to any other node is called as parent node. In other words, we can say the node which has one or more children is called as parent node. In tree, a parent node can have any number of children. I mean any number of child nodes. Look at this. I have taken a node A. Node A is a parent of what? B and C. I take a node B. Node B is what? Parent of D, E, and F. I can take the node C is a parent of what? G and H. This is what the parent is. Parent is what? At least it has one child. Then only we can say the node as parent. What is a child? The node which has descendant of some nodes is called as a child node. All the nodes except the root nodes, all the nodes except the root node are child nodes. Example, so I taken as node B. Another way you can say the node which has no, the node which has no children. The node which has no children. We can say it as what? Child node. Sorry, the node. Yeah. Okay. Look at these examples. So I take this node B as a child of what? The node D as a child of what? Node B. The node D, E, F are children of what? Node B. The node C as a child of what? Node A. Node G and node H as children of what? Node C. So I hope you're clear. What is child? What is the ancestor? What is the ancestor? Ancestor preceded you in a direct lineage. That is nothing but ancestor, nothing but what? If I take a particular node, that node parents, a grandparent, and a great grandparent, etc., are called as ancestors. Let us take the example of node E. So node E's ancestors are what? B and A. The node B is okay. I can say node B is ancestor of what? Node E. I can say node A ancestor of what? Node E. This is how we can represent. Let us take the node G. The node G's ancestors are what? C and A. I can say node A is ancestor of what? G and H. Right? So this is how we can represent ancestor. What is descendant? What is descendant? What is a descendant? So what is meant by descendant? It's the opposite case of your ancestor. So if I take any nodes which are children, grandchildren and great grandchildren, all those are called as descendant. So let us take the example. Let us take the example of B. The B descendants are what? D, E, F, I and J. I can say node number J as what? Descendant of what? Node B. I can say the node I as what? Descendant of what? Node A. I can say the node K as what? Descendant of what? Node A. I can say node K as descendant of what? Node G, node C and node A. I can say node H as a descendant of what? Node C and node A. This is the what? This is what? The descendant term in this tree. Let's take the one more example. Okay, next term, siblings. What is meant by siblings? The nodes which belongs to the same parent is called as siblings. The nodes which are belongs to what? Same parent, it is called as sibling. In other words, nodes with same parents are sibling. Let us take the example of node B. Node B is a parent, same parent for what? Node D, node E and node F. So I can say node D, E, F are siblings. Let us take the example of node C. Node C. Node C is a parent of what? G and H. So that for G and H, common parent is what? C. So I can say G and H are siblings. Let us come to this root node. Node A is a parent of what? B and C. So B and C as what? Siblings of what? I mean siblings. I mean B and C has same parent, that is node A. Next, what is meant by degree? So in this case, degree you have to discuss two terms. One is degree of a node, other one is degree of a tree. What is degree of a node? The nodes, okay, degree of a node, the total number of children of that particular node. How many number of children are they in that particular node? That is called as degree of node. What is the degree of a tree? Is the highest degree of a node among all the nodes is called as degree of a tree. So we'll take the example. We'll take the example. So I have taken same example what we discussed in the previous class. The node A has what? How many children? It has 2 children. So what is the degree of node A? 2. What is the degree of node 3? It has how many children? 3 children. So degree is what? 3. What is the degree of node E? It has 2 children. Is 2. So degree of all the leaf nodes are what? D, I, J, F, and all H. These are all degrees what? 1. So what is the degree of node C? It is 2. Why? Because node C has what? How many children? 2 children. So what is the degree of a tree? So I think you're clear with what is the degree of a node. So what is the degree of a tree? Which node is having highest degree? The node B has highest degree. What is the highest? What is the degree of node B? That is node 3. 3. Node B is what? The degree of node B is what? 3. So that this is the highest degree of this tree. So that the degree of a tree is what? 3. Okay. So next term is what? So in this case, okay, we discussed degree of a tree. Next, what is internal node? What is meant by internal node? The node which has at least one child is called as internal node. The internal node are called as non-terminal nodes. every non-leaf node is an internal node. So look at this. I will see that what is the leaf node. So leaf node is nothing but which has no children. The leaf node is nothing but what? It has which has no children. So that is what D, I, J, F, K, and H are called as leaf nodes. That's what internal nodes are called as non-terminal nodes, and every non-leaf nodes are called as internal nodes. So I can say A, B, C, E, G are called as non-leaf node. Why? Because it has children. So I can say A, B, E, G, and C as called as internal nodes. Why? Because it has children. So and it is a non-leaf node. So that's what we can say it as internal node. So I hope you're clear with the internal nodes. Next, what is subtree? So look at this. I taken a same example of employees of the corporation. So president, it has how many branches? Three branches. What is the first branch? So this is a president is a root. First branch is what? BP1. This is called as one subtree. This is also a tree. Subtree is also a tree. Next second subtree is what? BP2 branch. This branch. This is also a subtree, and this is again a tree. And third one is what? BP3 branch. Again it is a subtree. So the president, okay, root node, it has how many children? Has how many subtrees? Three subtrees. So what is a leaf? Look at this, the node which has no children. The nodes which has no children, that is called as leaf nodes. So I mentioned the nodes which is in green colored one. So manager 1, manager 2, worker B, and manager. All these are called as what? Leaf nodes. So next one is very important. What is meant by level? In a tree, each step from top to bottom is called as level of a tree. So the level count start with 1 and it is incremented by 1 at each level or step. Look at this. I take the same example. So the root comes under level 1. So the children of the root comes under level 2. The grandchildren of a root comes under level 3, and a great grandchildren comes under what? Level 4. It's so on. It goes on. This is how the levels says. So we always start from level 1. So look at this. The levels. The president is at level 1. VP1, VP2, VP3 are level 2. I mean level 2. Nothing but VP1, VP2 are what? Children of the president. So children of president comes under level 2. As other way, the children of what? Root node comes under level 2. The next managers or the grandchildren of a root comes under level 3. And worker B, the great grandchildren of what? Root or president, it comes under level 4. So what is the caution here? In some text, this level starts from 0 rather than 1. So the root is at level 0. Its children are at level 1. The great grandchildren are at level 2. So and so on. So, but in this coming slides, so in our discussion, we always start with root at level 1. So what is the height? The total number of edges lies on the longest path from the leaf from any leaf node to the particular node is called as height of that node. Yes, what is the height of that node? Any number of edges from leaf node to that particular node is called as what? Height of that node. So height of a tree is what? It's the longest path. Height of a tree is what? Height of a root node. Nothing but height of a root node is a is a height of a tree. So what is the height of a leaf? Height of a leaf is what? 0. So what is the definition says? Height, number of edges from leaf to leaf is what? 0. That's what the number of edges from leaf to leaf is what? 0. That's what the height of a leaf node is what? 0. Number, what is the height of a tree? Number of edges, longest path. Number of edges in the longest path from leaf to what? Root is called as height of a tree. So what is the height of a node B? So what are the number of edges from its leaf? It has only one edge, nothing but what is the leaf for this? D. I mean left child is what? First child is what? D. So it is a leaf node actually. So from D to B is what? 1. So the height is what? 1. So second branch, I mean second subtree. The first subtree height is what? 1. Second subtree height is what? It has two parts here. One is BEI, other one is BEJ. So it has how many edges from BEI to BEJ is 2 again. So common is what? I take 2. In the third subtree, so we have only one node, that is a leaf node. So from F to B is what? I have only one edges. So what is our common here? Which is IS1. So 1, 2, 1. So IS is what? 2. So the height of B is what? 2. So what is the height of H? As for the definition, number of edges from leaf to its node. What is the node? H node. H itself is a leaf node. So height is what? 0. What is the height of a C node? Height of a C node. In the left subtree, we have a 2 edges. In the right subtree, we have 1 edges. So what is the maximum one? So it is 2. We choose the longest one. So what is the height of this root node? So I have three longest path. One is A, B, E, I, A, B, E, J, A, C, B, sorry, A, C, G, K. So one is what? A, B, E, I. Second one is A, B, E, J, and A, C, G, K. Again, these three paths are the longest path. So again, the height is what? 3. So what is the height of the tree is what? What is the height of a tree? That is 3. Next, what is meant by depth? Depth, the total number of edges from root node to a particular node is called as depth of that particular node. What is the depth of a tree? The total number of edges from root to the leaf node in the longest path. The total number of edges from root node to leaf node in the longest path is called as depth of a tree. So what is the depth of root node? It is 0. Why? Because number of edges from its root node. Because A itself is a root node. So if I take the node as A, number of edges from edges from root node to its node is what? 0. That's what. The height of a leaf is what? 0. The depth of a root node is what? 0. So let us take the example of a node AB. What is the depth of a node B? Number of edges from its root is what? 1. What is the depth of a node I? Number of edges from its root is what? 1. A to B is 1. B to E is second. And E to I is third one. Nothing but total is how much? 3. Depth of I is what? 3. What is the depth of K? Depth of K is what? From K to G, 1. G to C, 2. C to I, 3. Nothing but number of edges from its node to its leaf node is what? 3. What is the depth of a tree? Which is the longest path? Again, it is 3. We will get 3 longest path from K, from J, from I. So depth is same. So depth of a tree is what? So which is the maximum here? It is 3. Nothing but longest path. So height and depth. Look at this height and depth of a level. So nodes in degree. So the president, it has I can say nodes in node degree is equals to number of children. As I said, what is the degree? Nothing but it's a number of children of that particular node. So what is the degree of a president? It has 3 children, so degree is 3. What is the degree of VP1? 2. Degree of VP2 is 1 because it has 1 child. Degree of VP3, it has 1 child. Then degree of a manager is what? Manager 1, 0. Manager 2, 0. Manager comes under VP2 is 1 because it has 1 worker B. Again, manager under VP3 is 0. So worker B is what? 0. So this is how we can represent no degree. Tree degree, maximum no degree. So what is the maximum? What is the tree of degree of a tree? What is the degree of a tree? So which is having a maximum number of nodes? Nothing but maximum number of degree. What is the maximum degree here? 3. Nothing but which node is having highest number of children? That will be your degree of a tree. Nothing but what is the degree of a tree? It is the degree of a tree is what? The degree of a tree is what? 3 because which is having highest degree? There is a president is having highest degree, that is 3. So degree of a tree is what? What? Degree of a tree is what? That is 3. So I hope you are clear with the terminologies. Thanks for watching.